begin by briefly discussing the historical evolution. Hello, this is Susan Raaymakers presenting the cognitive theory of multimedia learning. I will begin by briefly discussing the historical evolution and authorship of the cognitive theory of multimedia learning. In the 1990s, Richard Mayer introduced the cognitive theory of multimedia learning, which he defined as learning from words and pictures. To assist in explaining and predicting a variety of learning outcomes, the cognitive theory of multimedia learning incorporates other previously established theories, including information processing model, often credited to George Miller, who presented this model in 1956, Pavio's 1971 dual coding theory, also called the dual channel theory, and the cognitive load theory, which is a cognitive learning theory introduced by John Sweller in 1988. Now I'm going to discuss the key elements of the cognitive theory of multimedia learning. The dual channel theory suggests two distinct channels in the human information processing system. One of these channels processes information presented in a visual or pictorial format, while the other processes information presented in an auditory or verbal format. Verbal learning involves learning from both printed words, such as the bullet points on this slide, or spoken words, such as the words you are hearing from me now. Pictorial learning is achieved by graphics or dynamic graphics. For example, the graph on the right depicts statistics regarding candy corn affinity, whereas on the left, this is an animated image of, well, you can see a cat skiing. Based on the idea that humans process the information they receive, rather than merely responding to stimuli, the information processing theory likens the mind to a computer in which the mind is responsible for analyzing information from the environment. This model includes attention mechanisms for bringing information in, working memory for actively manipulating information and encoding, and long-term memory for passively holding information so that it can be used in the future. As you can see in this diagram, in sensory memory and working memory, there is potential for discarding the information, which equates to forgetting. Also in this model, the strength of encoding the information in working memory is strengthened by rehearsal. Sensory memory holds an exact copy of what was presented for a very brief time, approximately less than 0.25 seconds. Working memory holds a more processed version of the information for a short period of approximately less than 30 seconds. Long-term memory holds the learner's entire knowledge base for a long period of time. The effectiveness and efficiency of this process is limited due to capacity constraints in the two areas of working memory and sensory memory. Working memory is restricted to processing only a few pieces of information at any one time. Therefore, material must be compressed and organized into meaningful chunks to work within the constraints of limited processing capacity of working memory. Visual and auditory channels leading to sensory memory are restricted and therefore limit the amount of sensory information that can arrive in sensory memory. This illustration demonstrates the information processing system as proposed by the cognitive theory of multimedia learning. There are 5 main types of cognitive processes. The first two, selecting words and selecting images, refers to intentional attention to spoken words and images respectively for further memory working processing. The next two types of cognitive processes include organizing words and organizing images, in which this information is mentally rearranged into either a verbal or pictorial model in working memory. Finally, integrating refers to mentally organizing the verbal and pictorial models together and integrating with relevant prior knowledge activated from long-term memory. Using words and images, meaningful learning occurs when the learner engages in all 5 cognitive processes during learning. In this theory is helpful to understand that there are three key elements influencing the learning process. Extraneous processing is cognitive processing that does not serve the instructional objective. Essential processing, which is cognitive processing of the main points of multimedia presentation. And generative processing, which refers to cognitive processing aimed at making sense of the material. Extraneous processing is caused by poor instructional design in which the learner is presented with information not germane to the educational aim. Although perhaps interesting, information irrelevant to a learning objective requires processing and results in extraneous cognitive load. Mayer suggests 5 principles for reducing extraneous processing. Adherence to these principles assists learners by reducing mental processing involved in trying to focus on important information and matching segments of information together. The coherence principle suggests that individuals learn better when extraneous material is excluded from a multimedia lesson, such as this clip. The signaling principle states that people learn better when essential words are highlighted. The redundancy principle states that people learn better from animation with narration only, as compared to animation with both narration and text. An exception to this is when the text is short, highlights the key actions described in the narration, and is placed next to the portion of the graphic that it describes. For example, this clip shows a dog head with human hands typing on a laptop. As compared to this presentation, showing a tan dog wearing a black coat typing on a laptop with human hands. As you'll note, you have the key points of this information. Spatial contiguity states that learning process is supported by presenting corresponding words and pictures in close proximity. Temporal contiguity suggests improved learning when corresponding narration and animation are presented simultaneously rather than sequentially. For example, verbalizing the words at the same time they are illustrated in the animation. If my description of the animation is not occurring at the same time, this requires increased processing. For example, if I were to say something like, the yellow cat, and then the white cat, and yellow, white, yeah, there's the white cat, versus yellow, white, yellow, white, yellow, white. Essential processing is the process of mentally processing the essential material from a lesson in working memory. So it is important to assist learners in managing essential processing without overloading the learner's cognitive capacity. Mayer suggests 3 principles for managing essential processing: pre-training, segmenting, and modality. Pre-training refers to defining key terms prior to the main lesson content, enabling the learner to focus only on the content. The principle of segmenting refers to improved learning when a narrated animation is presented in a learner-paced segment rather than as a continuous presentation. The modality principle aims to efficiently use both verbal and visual processing channels by suggesting that individuals learn better from graphics with spoken text rather than graphics with printed text. Generative processing, which is the cognitive process of making sense of material, is fostered by adherence to these 2 principles: multimedia principle and personalization principle. The multimedia principle suggests that people learn better from words and pictures together than words alone. Combining words and pictures allows individuals to create connections between their verbal and pictorial models. For example, listen and watch the animation of the cheetah. At an average speed of 64 miles per hour, the cheetah is the fastest animal. The personalization principle is that individuals learn better from a multimedia lesson when words are conversational rather than formal. Conversational style encourages feelings of being part of a discussion, which encourages more of an effort to understand what the other person is saying. Now I'm going to talk about the cognitive theory of multimedia learning strengths and limitations. The strengths of the cognitive theory of multimedia learning include the basic underlying framework of well-established theories of learning. Research suggests effectiveness of strategies to reduce extraneous cognition, manage essential processing, and support generative processing. And the theory is expanding into new areas of instruction, such as medicine, that will allow this theory to continue to evolve. Limitations include unknown influence of metacognition and affective factors in multimedia learning. There's also been contrary results of a research study which indicated that pictures combined with words did not support or hinder learning, and that due to the framework foundation of the theories of the dual channel, information processing, and cognitive load theories, the cognitive learning theory of multimedia learning is inherently subject to the same limitations of its baseline limitations. The last part of this will be to apply the cognitive theory of multimedia learning. The cognitive theory of multimedia learning can be applied to both children and adults. It can be in traditional classroom settings in which an instructor presents information on an overhead screen using both pictures and words. This theory is also very applicable to learning online with video, text, and animation instruction, and can be both in online taught courses, formal courses, or it can be in other informational venues, such as public information. 3 examples of applying the cognitive theory of multimedia learning, including only relevant material in the information presented for minimization of extraneous load, as you saw earlier in this presentation. Defining key terms before discussing the concept to allow learners to apply knowledge of terms to the concept rather than learn both terms and the concept concurrently. And placing labels in close proximity to the associated images to best use spatial contiguity. Here are my references. I want to thank you very much, and I look forward to hearing your comments. Have a good day.